Good day. Today we're looking at applications of matrices. Anytime you look at a picture on a screen, you are looking at a still image which is made by combining hundreds of thousands or even millions of squares of pixels. Manipulating these pixels is what creates the image that you can see. If you divide an image into a grid, that is what creates your pixels. And every single square in that grid is changed in reference to brightness and the color. For example, consider the diagram of the capital L below. On the left, we can see the still image L because we're not moving the screen. You can take a picture of it. This capital L is formed using a grid of 4 colors, being white, light gray, dark gray, and black. If I was to define this grid, it is a 3x3 matrix. The L portion is dark gray, so 2, 2, 2, and 2. The rest of the squares are light gray, so they're all ones. This set of a matrix is what creates the L in the picture. Now let's change the contrast of this letter L. Let's make it darker. And we're going to use this by matrix addition. So my L is 2, 2, 2, 2, 1, 1, 1, 1, 1. Now I want to change the contrast on this. I want to make the dark gray darker and the light gray lighter. So for the dark gray, I'm going to add 1. For the light gray, I'm going to subtract 1. To get a solid black L, my matrix would be 3, 3, 3, and 3 for the L, and then 0 for the other blocks. Alright, that would be a solid black L. To show you a better example of how this works in photographs, look at the image of Saturn, I believe it is, of Saturn, which is made out of the pixels. And you can read about that. I just wanted to include that for you to see. Another application of matrices is moving figures. So if we look at this quadrilateral, we can take the x values of this quadrilateral and pair that with the y values of the quadrilateral as a row 1 and row 2 numbers. So I have -1 and 2, I have 3 and 4, I have 1 and -2, I have -2, -3. Okay, you just go around the figure. There is a matrix that would represent this quadrilateral. If I wanted to move this 4 units to the right and 2 units down, I'm going to title this M just for a little bit of time saving. I would take my matrix M and I would add 4 units to the right, so 4 for all my x values, 2 units down, -2 for all the y values. Okay, from here, I do -1 plus 4, 3, 3 plus 4, 7, 1 plus 4, 5, -2 plus 4, 2, 0, 2, I'm subtracting 2, -2 minus 2, -4, and -5. There's the coordinates of the new quadrilateral. If your directions were to shrink this quadrilateral to half the perimeter, you would take the scale factor 1/2 and you would multiply that to matrix M. negative 1/2, (3 divided by 2, 4 divided by 2, 1 divided by 2, negative 2 divided by 2, negative 2 divided by 2, negative 3 divided by 2. That has half the perimeter of the original quadrilateral. Let B be that matrix. Find BA. How does this affect the diagram? So I'm taking negative 1, 0, 0, 1, and I'm multiplying it with negative 1, 3, 1, negative 2, 2, 4, negative 2, negative 3. Okay. Now I'm not going to work all of this out because you should be able to know how to do matrix multiplication at this point. I do want to point out the first thing you should check, does this actually work before you start? B is a 2 by 2. I am multiplying this by A, which is a 2 by 4. My result will be a 2 by 4. These matched, I'm good. Okay. I'm going to do the X column part of it and write it out for you. Taking my negative 1 times my negative 1, my 0 times my 2, negative 1 times my 3, 0 times my 4, I'm going to do the first two for the Y column. 0 times negative 1 plus 1 times 2, 0 times 3 plus 1 times 4, and then blank blank for the last two. I'm just going to write the answer. When I do this, I'm going to get 1, negative 3, negative 1, positive 2. I'm going to get 2, 4, negative 2, 3. Negative 3. I want you to notice in this matrix BA, then from the original matrix, your X values have flipped the sign. Therefore, what this transformation has done is reflected my matrix over the Y-axis. I want you to try this triangle problem. Go ahead and pause the video. All right, let's move on to one more. The table below gives an estimated of age, range, sedentary, not moving, this is what that means, moderatively active, and active, for males and females with their, I might not say this word right, but their calories per day. Represent the caloric need by age and activity level for the men group and label it matrix M. Only thing this is asking me to do is take my M group, and I'm pulling out the 24,000 or 2,400, 2,200, 2,000. So I'm pulling out the blue values per column. $27, $25, and $23. And $30, $29, $26. There's matrix M. Now I'm going to let you try number 2, and I want you to find M and W and explain that. What do you think that means? Now I'm also going to get you to do this problem. So these are real world modeling problems. But something I do want you to notice. On number 2, it says, how many female Republicans are there? Now, after you do this problem, that will probably make sense, but I want to remind you of something. Whenever we do matrix multiplication with row M, column R times row R, column N, the result is M by N. Okay? Row and columns have to match. The top graph has political parties on the left side. For the rows, it has age as columns. The bottom graph has age for rows and your sex for the columns. Whenever you multiply this, you're taking party by age, you're taking age by sex. The result that you get will be party, political party, as each of your rows, and sex as your male and female column. That is just a helpful hint to help you with number 2. All right, pause the video for each of these problems, try these, and that's all I have for you today. Have a great rest of your day.